Hello, my name is ArcGIS, and in this tutorial I want to show you how to create tracks and routes for RailInspector by using ArcGIS. We start with creating an ArcGIS map. So we start ArcGIS. And we want to use OpenStreetMap as a base layer. So what we do is we go to ArcGIS Online, and we look for OpenStreetMap. There it is, and we open it. So now OpenStreetMap is used as a base for our content. We will name this map RailInspector Geodata. We have to choose the projection. In this case we will use the Dutch coordinate system. So we choose here projected coordinate system, national grids. We go to Europe, and the Dutch national grid has the abbreviation RD, and we also have to select the transformation we want to use. So this transformation is used to have satellite data into your projected coordinate system. In this case we choose this transformation. Okay, we say apply. Of course, if you live in a different country, you want to use your own national grid. Now we want to save this data, and we go to our data path, which is C, data, path to data here, and we call this geodata. Okay, so this is the basis. Now, next step is to add the railway network or part of the railway network to your map. I have it here in the file input, and this is a shapefile containing the railway network. I project it here, you can see it here, I can zoom in. This is in the south of the Netherlands. It takes a little while before the map background is generated. You can see it here that it's loading data from the internet. This only takes time the first time because ArcGIS will have a cache of this data. There it is. So I can even zoom into my real network, zoom to layer. Okay. To make it a little bit more visible, I will take. Okay, so there's the part of the network. If you think it's too bright, then you can always use here. Use a transparency, for instance, set it to 50%. Now it's better. Okay. Next step. Okay, we have been with our measurements on part of this network, and we have the PAC GPS data available. So we want to know more or less where we have been. Well, the PAC data is stored in a text file. I have it here. So I took the PAC data, gave it the extension .anemia. I can open it, and then you will see. Okay. I have to open it with a text. For instance, with Notepad. Okay. Oh wait, it's here, yes. So here I have the data, GPS data per dynamic, and these are the sentences that are stored which give the position data as a function of the time. Okay, so this is where it is stored in a text file. These text files cannot be read by ArcGIS, so we have to convert them. And for that we use a program which is called GPS Babel. It's an open source program. So I use GPS data and I want to store it in a file. And GPS data.kml. Yes, I want to replace it. And I want to export it in KML, which is Google Earth format. And the input format is anemia. So conversion is running and is ready. Okay, if you have Google Earth installed, then you can click on the KML file and it will open Google Earth. I can see this is where we have measured. Okay. I don't want to keep it. Okay, so now this KML file can be read into ArcGIS. For that we use a tool. You can either look it up in the toolbox, like this, but it's always difficult to find, so I prefer this method, which is called use the search box. Let's make it a little bit smaller. Oops. Not this one. Put back. Okay. I say here KML. Okay, I want to read from KML, and then it opens the correct tool. Yes, I want to do a KML Tool layer, so I use this input file, GPS data, and where do I want to store the result? I think in the same folder, so not here, but here. Oops. Here it is. That is a bit difficult. Path to data. Okay with the name. So now it's reading the KML file and projecting it on the same map. There it is. Okay, so you see if I zoom in, you see the individual GPS points. See every point that is measured on the track. I don't want to see the points because so I can safely remove them. Okay, and then I have the track where I have done the measurement. I think the line is a little bit too thick, so I'll say okay, I make it too wide. The next thing we want to do is to add a route and a track field to the rail network layer. We can do this in two ways. We can do this by adding a field to the attribute table. Okay, we call it track this. Or another way is to use Python. Open a Python window. I can paste a command that I already have prepared. This one. This basically does the same. It adds a field to a real network. The field is called root. It's a text field. So if I execute this, let's see, it has executed, and we can check here the result here, and you see we have added also a root field. The next thing we want to do is to select the parts of the network where we have done the measurements. So we have to select the individual track elements and assign a name to the track and to the route. Okay, let's close the Python window here. Zoom in a little. Okay, so selection is done by the select tool. Choose this one, and I can click on the lines, and if I hold shift I can select multiple lines. Okay, so this is the first. I zoom to the selected features. Again, I can switch off the base map, so it goes a little bit faster. I zoom in again. First I take the north part. Okay, more zoom. Choose the selection again. And I repeat this process until I've selected all parts of the track. Okay, I'm almost finished with the selection. Just a few more parts. And then I'm finished. Okay, so you see, I selected the whole part between the two stations, and now I can set the route and the track information. So I give this track a name. I can see here that we have the selected items, and I can assign a name by using field calculator and saying, okay, track is track 1. Okay, a failure. I think I used the wrong quotation marks. Not sure. Yes. Okay. And I also can assign the routes. Well, I can do it the same way using the field calculator. I also can do it with Python. I can show you. And this is this command. So I assign in the layer rail network to the field route the name route 1 and route 2. So I assume this is part of 2 routes. Finished, and I can check the results. here. Okay, yeah. So you see everything is assigned. And in the non-selected items, there is nothing assigned. Okay. So we leave the selection as it is, and we go on with the next step. Now the next thing, what we need to do is to merge all the parts of the track that have the same track name. Because in RailInspector we need a single feature for each track for the distinguished name. But to merge it, I first have to check if the kilometers are okay, if the change is consecutive. So open the attribute table, I sort the kilometer field, and then I just check by hand if the kilometer 2 from a previous record equals the kilometer from the next record. You can check for yourself that this is the case for this. So after the merger, the kilometers will go on and there's no gap or something like that. Okay, so if I'm convinced this works, then I need to use the dissolve tool. I can find it here. The dissolve tool is used to merge the track parts, and it only works on the selected items. So first make sure you have the selected items. I want to dissolve features from Rail Network. I want to store it, let's say I store it here, and I want to call it routes and tracks, but shit. Okay, so I want to merge everything that has the same track and route fields. And then what I also want to do is to have a kilometer from field and a kilometer to field in the output. So the kilometer from should be the minimum value of what we have from kilometer from, and this should be the maximum value. So it takes from the list the minimum value of kilometer from and the maximum value of kilometer to. I don't want to create multiple features, and I want to unsplit lines that are maybe split. And then to prevent the bug in ArcGIS, I need to disable the output of Z values. We don't need them in the RailInspector, so this is set to be disable. Okay. And then run the tool. You see that it's running. And now it's ready. It has created a new layer with the same name, routes and tracks. And this layer, I can show you what it contains. It contains one element with track and route, and it has the minimum and maximum kilometer values or change values. And this is the end result that we can use in RailInspector. So I can close this and open up RailInspector. Now I have created a shapefile with the routes and tracks. I can use it in a RailInspector project. So let's open RailInspector. Then what we can do is create a new project. I call it a demo project. Project demo point 16.1. Demonstrator. And I'm the operator, and the client is the customer. Okay, then I can go to routes, and I can say, okay, I want to add routes. And I take the newly generated shapefile and open it. I have to say, okay, which field contains my track name, that's in this case the field track, and which field contains the route names, that's route. I say, okay. And you can check for yourself that we have the complete route now available. Route 2 is the same, so we don't see any the mouse wheel and I can check for myself that everything is in order. So this concludes the demo of creating routes and tracks for RailInspector. Thank you for your attention.